Okay, part 2 to the lesson today. We already finished the review, so hopefully everybody has watched that. Now, what we're doing today is we're just doing a little tiny bit more work on turning pattern rules into expressions. So it's just only this one page today. Yesterday was a huge lesson. So just a bit more practice of the exact same thing today. So subtitle is Pattern Rule to Expression. Okay, so again, here's a reminder of our steps. The first thing that's most important to do, as you would have seen modeled in our homework review from yesterday, is you have to determine the values that are in the input-output machine that relate the input to the output. So that is what we practiced all last week. You guys should be pretty much masters at that by now. The second thing is adding in a variable to represent the input. So, yep, that's also what we practice. So usually the variable goes next to the first machine. Okay, so example, here we go. We're putting our pattern rule into an expression. So here we go. Our first one is if it was times 4 plus 3, if this was our first machine, this was our second machine, what would our pattern rule be? Okay, let's write that in. So it would be, if we were in class right now, I'd have you guys do this. Yeah, but you're just gonna follow along. So here we're gonna say 4i, because that shows multiplication, right? That's a sneaky little multiplication in there. And then it's just going to be plus 3, okay? That's our expression. I could have done it over here. I could have said oh, that's noisy car. You guys can hear that probably. I times 4 and then plus 3. Okay, so that you could also easily do. Okay, the next one is 5. Rather than using an I this time, I'm going to change my variable. I'm going to use an N instead. And then we just add on the last one, which is minus 2. Okay. Ooh, we haven't seen this yet. What if it is divide by 2? Okay. Then I have to put, in this case, I'd have to put my variable first, okay? So for this one, maybe I'm gonna do my variable as a smiley face, because you can also do a symbol if you want to, okay? Sure, I'm gonna do a little smiley face because it can be a symbol. And then I'm gonna do my smiley face divided by 2. And then after I get that answer, then I'm going to add on 5, okay? So that's one option. Or the other thing you could do for this one, I'm going to use n again, just as like another, just different variable. You could do n divided by 2, because this means the same thing, right? And then plus 5, okay? Either of those would mean the same thing. If we have this over a number over this, it would be the same thing as divide, okay? So any of those options would work. And then I just put a little reminder over here if you want to write this in. Remember, when a number touches a variable or is next to it using brackets. So say, for example, we had this like 5 and then we had brackets x, for example. That's the same thing again as multiply, okay? That means the exact same thing. Yeah, this means to multiply, okay? So this is just kind of one of those like math things. It's just a rule. It's just what like any mathematician or engineer, anyone around the world would just know that this is just how it is in math. Yeah, so if you want to write that in as an example, 5i or 4x or whatever is the same thing as 4 times the variable. Okay, right on. So that is it. And this is your homework. So it is pages 22 and only page 22, questions 1 to 3. I would like you to do number 1 on Seesaw, which I'm going to show you right now. So this is the page 23, oh, it's 22. Oh yeah, I wrote that, okay. Page 22. So this is the question that's going to be on Seesaw, which I'm going to show you in a moment, okay? So you have to do all of this. Pretend that you're building these car toys, and then you have to make a table to show the number of wheels that are needed for 1 car all the way up to 5 cars. Then you have to write the pattern rule that relates the number of cars to the number of wheels. So that's the pattern rule we did like all from last week. Then this is the new bit, write the expression that relates, that represents the pattern. find the number of wheels that are needed to build 11 cars. And I would like you to show your work. Okay, this is going to be in Seesaw. Number 2, this is the exact same stuff as what you had from yesterday in the workbook. Okay, so all you have to do is just find the expression, but we know we have to find the pattern rule before we're able to write the expression. And then this one is similar also to the workbook from yesterday, which was the triangles. You need to make a table to show the number of figures in all of these different figures, so number of squares in each of these different figures. If you're stuck, you can go to the question that we just reviewed with the triangles. That would show you how to set up a table. And then write the pattern rule that relates the figure number to the number of squares. Okay, so that's start at this, increase by whatever each time. Write an expression, so that's the practice we've just been doing. And then find the number of squares in the 7th figure. So again, you have to apply the pattern rule. And that's it, okay? So this is the page template that I've made up for you for Seesaw, okay? It's the exact same thing. The only thing I've added in is I would like you to label the table with the appropriate heading. So what would you call this? What would you call this, okay? And I want you to think of something other than input, output. How can you relate the table headings to the actual context of the question, okay? Hopefully that you can think through that. It's kind of like science, mathematical stuff. What would make sense? What would you put here? What could you put here? Then you fill out the table, pattern rule, write the expression, and then tell me how many wheels would be needed to build 11 cars, and then please show your work, okay? That is due tomorrow. Good work.